wave motion and waves on a string. In this presentation, we will define wave motion and then we will discuss sine wave traveling on a string. Wave motion is nothing but the transfer of energy. It is a way to transport energy from one point of space to the other without any bulk motion of material together with it. It is a kind of disturbance that travels through a medium due to repeated vibration of the particles of the medium from its equilibrium position. It is a mean of transfer of energy and momentum from one point to another of the medium without any actual transportation of matter between the 2 points. Now we will discuss classification of wave motion. Usually there are two types of waves: mechanical or elastic waves and non-mechanical wave or electromagnetic waves. The waves which can propagate only in a material medium are called mechanical waves. Means here medium is required for propagation. For example, the waves on water surface, sound waves, waves on the string, etc. The waves which can propagate without a medium are called non-mechanical waves. Here, for propagation, medium is not required. Examples: light waves, radio waves, gamma rays, X-rays, etc. Now, mechanical wave motion are of two types: transverse wave motion and longitudinal wave motion. A wave motion in which the particles of the medium vibrate perpendicular to the propagation are known as mechanical waves motion, particularly they are transverse wave motion. Examples: electromagnetic waves and waves on string. Longitudinal wave motion can be defined as a wave motion in which the particles of the medium vibrate about their mean position along with the direction of propagation. An example for sound, it is sound wave. Now next, sine waves traveling on a string or waves on a stretched string, or you can say that a mechanical wave in one direction. Let us consider a long string with one end fixed to a wall and the other held by me. Suppose by me. I pull on the string keeping tight and snap my hand a little up and down, producing a disturbance for a very small time. What happens as time passes? As time passes, for an elastic and homogeneous string, the disturbance moves with constant speed to cover equal distances in equal time towards right. Here, different parts of the string are successively disturbed, transmitting the energy from left to right. We can say that a wave pulse is passing through the part of the space. See, this is nothing but the transfer of energy due to the disturbance created by myself. And if the string is homogeneous and elastic, the characteristics of string is elastic and homogeneous, then the disturbance is for very short time, this we can introduce this disturbance as a wave pulse. If the source is repeating its motion several times, we get a wave train. It is known as sine wave. See, due to the repeating motion of the disturbance, wave packet or sine wave can be introduced. The direction of propagation of sine wave on a string is perpendicular to the direction of particle oscillation. So, sine wave propagating on the string will be the transverse wave. Now, let's understand the mathematical analysis of this configuration. Suppose disturbance is created at one end of string at time t is equal to 0 and it finishes at time t is equal to delta t. The vertical displacement y is 0 for time t is less than 0, has non-zero value for 0 is less than t is less than delta t, and again it becomes 0 for t is greater than delta t. Let the function f of t be the displacement y of the particle at x is equal to 0 as a function of time. Means y of x is equal to 0, t is equal to f of t. Now we know that the disturbance travels on the string towards right with a constant speed v. Displacement produced at the left end at time t reaches at point x at time t plus x upon v. I would like to repeat again the same thing. The displacement produced at the left and at time t reaches at point x at time t plus x upon v. Similarly, the displacement of the particle at point x at time t was originated at the left and at the time t minus x upon v. See, again I would like to repeat the same thing. That's why we can understand clearly the displacement produced at the left end at time t and at x is equal to 0 moves with velocity, constant velocity v on x axis and reaches at point somewhere x at time, it takes time t plus x upon v. Therefore, we can say that if we have a particle at point x at time t, suppose the displacement is x and time is t, then we can say that it would be originated at the left end at time t minus x upon v. Right. Therefore, displacement of the particle at x at time t will be the function of y of tx, or you can say that y of x is equal to 0 and t minus x upon v. See here. Therefore, wave equation B y of x t is equal to f of 0 t minus x upon v, or you can say that the displacement on y-axis of the particle will be the function of time in such a way that it is f of t minus x upon v. Now We know the equation of simple harmonic motion is f of t is equal to a sine omega t. Why do we take equation of simple harmonic motion? Because we have considered that the the disturbance is created for a very short time, and the string is elastic and homogeneous. Therefore, the repeated disturbance which is created on the string is give simple harmonic motion. That's why the equation of simple harmonic motion is introduced here to understand the mathematical expression of this wave motion. Here f of t is equal to a sine omega t, where a becomes amplitude and omega is nothing but the angular frequency. Now, as we have discussed that the wave equation be y is equal to f of t minus x upon v. Now, in this simple harmonic wave motion time t, we need to replace it by x minus t upon v. Therefore, the wave equation of sine wave traveling on the string at x and at time t will be f of t is equal to a sine omega t minus x upon v. Now let's think about the velocity of the particle at x at time t. It would be given by del y by del x. How do we get it? By taking the derivation of the wave equation, and here the x is considered to be constant. Therefore, del y by del x will be del y by del x is equal to a omega cos omega t minus x upon v. This is the velocity of particle which moves up and down with velocity del y by del x, which changes with x and t according to above equation. See, del y by del x is the velocity of particle in y direction. It is quite different from the velocity v. This velocity is totally different from the wave velocity v, which moves on the string at a constant velocity along the x-axis. Again, I would like to distinguish between both the velocity. Del y by del x is the velocity of particle in y direction, and velocity v is the velocity of wave in x direction. Thus, in this presentation, we had discussed wave motion, and then we have defined sine wave on the string. How does it propagate? And then we have tried to express the mathematical presentation of sine wave on a string. Thank you.